RBS Business Research Academy welcomes to you in the lecture number 46. In this lecture number 46, we are going to understand a wonderful and recently added a new feature in the SmartPLS, and its name is a CB-SEM. You're looking here, this is a CB-SEM. It means a covariance-based structural equation modeling. So basically, there are the two approaches where you can perform the structural equation modeling. One is a VB-SEM, variance-based statistical equation modeling. So what is right now we are performing in the smart PLS. So whenever we are performing any algorithm of the smart PLS on our data, that is called the VB-SEM, variance-based statistical equation modeling. Other approach or other algorithm is the CB-SEM, covariance-based statistical equation modeling. Recently, the Smart PLS has added this new feature in the software. So now, what is the difference between the CB-SEM and the VB-SEM, and what are the different new options which are available in the CB-SEM? So this is an introductory video on the CB-SEM feature, especially the feature which is added in this software. So let's start to discuss this wonderful feature in this one. But before this one, my name is Dr. Rainbek Sumro, and I'm from Shakti University, Pakistan. So now this is a wonderful interface of the Smart PLS-4. So first of all, I want to show that here I'm right now using the version 4.0.93. So this version, if we click it, then we can have some more information about the CB-SEM. Like click it, and then you're looking here that in the version 4.0.92, which was released on the 2/4/2023. In this, basically, this feature was introduced. This was a pre-release feature, and then some additional list and some additional features were also introduced in this version. And then after 4.0.9.3, which was released in this month on the 18th of the May 2023. In this one, the new features have been introduced, like the introducced the CB-SEM release with enhanced capabilities. So many capabilities have been extended or enhanced. And then the PC option, principal component analysis for the PLS algorithm. So here two approaches are there, basically principal component analysis, and other is a composite component analysis. So component analysis normally we use into the VB-SEM, variance-based statistical equation modeling software, especially in the smart PLS, and this is the other principal component analysis which we are using in the CB-SEM softwares. So if furthermore different new options have been introduced in this one. So then that means the version by version, the different new, whenever the new things have been introduced, the complete detail is available on the all these new options which are introduced in the different versions. And then if you want to know about the CB-SEM, some detail is available here. This is a covariance-based statistical equation modeling provides results of the common factor. And as already I told you, the composite factor we perform in the VB-SEM software. Statistical equation modeling using the maximum likelihood approach. So now other software like the MOS, it is also using the maximum likelihood approach, like here. So MOs also use the this maximum likelihood approach. For example, if you come here, then in the estimation you're looking here, the discrepancy maximum likelihood approach. So other approaches are also there, but basically it uses the maximum likelihood approach, and this is the diagram or conceptual model which I developed in the MOs. Okay, and then for the CB-SEM, use a statistical model to estimate and test the correlation between the dependent variable, independent variable, as well as the hidden structures, all these. So furthermore, like this beta version. So this is a beta version, and so many changes are expected to occur in the future. So if you want to provide some feedback to them, they are also welcome the feedback. In the light of your feedback, they may introduce some changes in this feature of the CB-SEM in the smart PLS. So furthermore, different options are available in this one. And then if you are unsure that either what I choose, CB-SEM or VB-SEM, then these some guidelines are there. If you go through all these one, then according to the guidelines, you can choose either you can work on the CB-SEM or on the VB-SEM. And if you are working on the CB-SEM, the previously different softwares were there in which we were working, like the MOS. and then Listener, live on or package, and the Empress and certain other. And then if we talk about the VB-SEM, the different software like the SmartPLS, the wonderful software is here, and the PLS Graph, Red PLS, Gasica, Edanco. You're looking here, all the these softwares are the detailed list of all these are you looking here. But now the good thing is that you are not almost required to use any type of the IBM memos because now the CB-SEM and the VB-SEM both features are available in this software. So now it is really it's genuinely it's like the silver bullet. That means silver bullet means that it can solve all the problems. So one solution which is solve all your problems. So recent means that in this way you can say that the smart bits is like really is a silver bullet right now. Now, how to work on this one? So already I have done some work in order to save the time. So here, trial project in the CB-SEM is there. Just click it. So already I have created a one model. So now, again, it's very easy to create the model just like you were creating the model in case of the VB-SEM. Like just select all these one and drag this one and press the enter button, and you're looking at the latent variable has been here. So now you can connect this latent variable through this connector to this dependent variable. So everything is same. There is no only new thing this one, especially from the graphical point of view, and how you can create a latent variable almost as the things are same in the VB-SEM. Okay, so now here looking that the two things are this is our error term. So in the VB-SEM, sorry, in the CB-SEM, we have to provide the error term with the every hour indicator as well as with every hour dependent or endogenous variable. So you are looking these dotted lines are there. These are our correlations. So how to add these lines? So I'm reading this right now in order to tell you how you can add all these one. I'm also reading this one because this error term always appears with every dependent variable. So how to provide this error term? I'm discussing. Okay, so now I have deleted all the connections with each other. So now, first of all, we have to create a connection. How to connect this QPE with the BI? It's very easy, just like we were doing into the like the VB-SEM. Click it, and then if you click here, you're looking here that the error term has automatically appeared on the dependent variable. Then another one, then another one. So now, but for example, if another dependent variable, for example, this is also dependent variable, you're looking the error term is here, and this one again. So now the error term will appear according to the dependent variable. So now we are deleting all these one, and then we have to provide the correlation with all these one because it's the demand of the CB-SEM because it's a covariate. So our all the exogenous, only exogenous, they should be correlated with each other. How to create the correlation? You are looking here the double edge. This the our like the connector is there. Just click it and then select these two one. Automatically this will appear, and then select this one. So now we have correlated with the correlated QPE with the FQQ and the FQ with the SQ, but still there is no correlation between the QPE and the SQ. So now we have to create this one. So now our correlations have been created, and then this is our regression weight. So with every our independent or exogenous or endogenous variable, we have to provide a one regression weight. You're looking automatically regression weight has been provided by default by the software. So these are the error terms. So now it's done. So we have to change its position from just like here. It looks fine here and properly aligned with the BI1 and the latent variable. Okay, so now in this way you can create a one. What is very easy, no any problem, and these error terms are automatically created whenever you are dragging any variable over here. So now how to apply this? Very easy, just like CB-SEM. You're looking CB-SEM algorithm and the bootstrapping both are there. Select it, and then so here different options are available. For example, the covariance based statistical modeling is a factor-based approach to statistical equation modeling. It supports the common factor analysis and allows to estimate in the test model latent variable using the observed covariance matrix between the indicators. So where this covariance matrix is there. So all the options are good, but you must think about this one. This is a beta stage, and that means that genuine additions are expected to occur in the future. And then start calculations. Okay. So further, if you want to know about these options, then yes, these options are available. The detail is also available about all these options which recently we have applied. And furthermore, if you were furthermore here, so again, if you click it, maximum iteration count, then this sentence is there. The maximum iteration count optimizer will perform. The parameter should be high to ensure that a good model solution can be found. So default value is a 1000. You can also increase up to the 2000 according to your demand. But here we are working with the 1000 default value, and then the detail remaining about the remaining all are available right now. And then if you want to know further, then more information is also available here. Start calculations. So now our results are up here. So here in this one, you're looking in these are the drop down menus are there. Results are also available in drop down menu, and the results are also available in this tabular form. So in the first, you're looking ABE. So all the ABs are here. Composite liability, all the alpha values are here, just like when we were doing into the VB-SEm, Cronva alpha, and then the R square are also there. And then this variance, if you click it, then nothing will appear in this like the here. And then these are the variance. So variance now these are being appeared over here. And then outer weights are here. These outer weights, the outer weights and outer loadings are there. And if you do want to show them, just keep the blank button touched. And then unstandardized are there. These are standardized and these are unstandardized. So whenever nothing is written before this one, these are unstandardized. Normally we use unstandardized beta values. And then path coefficients are there. Standardized and unstandardized both are available here. And these are the correlations. So all the correlations are there, and then these are the magic of this one. So now already you are well aware about this one. So one more thing, which is the mostly we're using here, the standardized and unstandardized. Even though if you come here, you are looking here, say that a list of the standardized and list of the unstandardized in both are. So what is the difference between the standardized and unstandardized? So far, in order to understand this difference, let's go. So now this is a wonderful step is there. It's a standardized regression coefficient, and which is written by the Andrew Seigel and the Michael Wagner. So the book name is a Practical Business English 8th edition 2022. What he writes, that the best because the regression coefficient B1 to BK may all be in the different measurement units, direct comparison is difficult. And then a small coefficient may actually be the more important than the large one. So now it happens in the in this regression. Then the classical problem of the why we are using standardized. So now classical example of this one is here. That this is the classical problem trying to compare the apple with the orange. So when if you do not standardize, then means that we are comparing the apple with the orange. So now that means that both are completely different things, and these two different things we are comparing with each other. It is better to standardize your regression coefficients to eliminate the problem by expressing the coefficient in terms of single common set of statistically reasonable unit that comparison may be at least attempted. For example, here they have given one example. Okay, but this one. So regression coefficient beta will indicate the effect of the change in the x1 and the y with all the out of the other x variable unchanged. Okay, the measurement unit of regression coefficients are BR unit of the y per unit of the. So here the measurement unit is our, in case of the is a y. So they have given a wonderful example here that if the y is a dollar of is the dollar amount of the sales and x is a number of the say people in the sales force, then the B1, that means your independent variable is in the unit of the dollar salesperson. Suppose that the next regression coefficient B2, another independent variable, is in the units of the dollars of the sales per number of total miles traveled by the sales force. The questions is which is more important, sales stop level or the travel budget? Which one is more important? So that's why we have to standardize all these one, as we should have only one value, standardized value for every independent variable. So now how to standardize? This is the formula, so through which you can standardize. If you find time, you can go through the rest of this one. It's a wonderful step in order to understand the difference between the standardized and unstandardized. So here we are using unstandardized because that means the what are the weight items are there. These items we have measured this item on the 5-point Likert scale from QPE1 to QPE4, FQ1 to FQ6, SQ1 to XQ4, and B1 to B6. All these items have been measured at the level of the 5-point Likert scale. So from strongly agree to strongly disagree. So now that's why there is no question to use the standardized. Now, for example, for someone, if you're using the 5-point Likert scale, for example, for QPE, and for the AK, if we're using the 3-point Likert scale, for another, we are using the 6-point or 7-point Likert. So now the difference in the measurement units is there. So then we can use the standardized. So already there is no only problem. So we should prefer the unstandardized. So whenever nothing is written before, after any level like outer weights or loading, so here it's an unstandardized. Otherwise, standardized word has been written or is being appeared here. So now these are standardized coefficients are our coefficients are there, and then total effect is there, indirect effect are there. So mean that so far there's no indirect effect, and then outer loadings are there. These all are the outer loadings are there, and then latent variables are here, and then factor score, and one important indicator data is there, and one important thing which very important for us, that's about the quality. In the quality you are looking okay, model fit. So these are the goodness of fit indices. So normally whenever you are using the covariance based algorithm, we have the several goodness of fit indices, like here you're looking the different goodness of fit indices you are looking here. For example, there are three categories are there. One is the absolute fit in Meyer, and then incremental fit Meyer, and another is the parsimony fit measurement. So these three are there where we can we apply these three major categories of the goodness of fit indices. These are the fit indices: goodness of fit index, JFI, or Ramsey, RMR, SRMR, norm chi-square, standard root, okay, and then NFI, CFI, AGFI, and the PNFI. So normally these are the goodness of fit indices, and these are their benchmarks are there. So now if we are meeting all these one, that's a wonderful, and then if not, then you have to you have to edit the results. Some options are available in the MOs over there. So now furthermore, there's also the difference between the PLS-SEM and the CB-SEM. If you are interested, you can also go through these. So now, whatever the good fit in which I have shown to you, so you're looking the same one over here. So now, almost all the goodness fit of fit indices you are looking here. So now their values are there. Those values in the black color, they are somehow higher than this one. Those which are in the red color, they are higher than those. So these are the issues. These are not so issues. So now somehow you will also get some values in the green color. Whenever any value is in green color, you should be happy that there is no any problem with this one. So normally there's this SmartPLS also provide all these GAOFIs. That means the goodness of the fit indices over here. Like the other CB-SEM software, they are providing to you like the IBM MOs. And then R squared is value is over here. The discriminability for Laker criterion, heterotrait, monotrait, all the values are available here. And then we are applying the CB-SEM bootstrapping. So here in the CB-SEM bootstrapping, the 5,000 sample is suggested, and the bootstrapping is a non-parametric procedure to test whether the model estimates from the CB-SEM results are significant by determining their standard error by using the desampling. So now if you want to know more, then you click this more. So now this procedure may take some time. So it depends on the quality of the machine or hardware. So now depending on the quality of it may take less or more time. So I have used a 5,000 sample size. So it is suggested all the time. So now start the button, it will start the calculations. So here results are before us. So in this one you are finding in outer model standardized results and the unstandardized results. So standard with their p-value and the t-value, standard with their p-value and t-value. So now here, if you click here, then these are our results are there, and then these are results of our inner model, like the structural model you are looking here. These three results are there. Again, these results have been provided to you in the form of the standardized along with the p-value and t-value and unstandardized. So now, furthermore, path coefficients, so results are available here, except only just one service quality behavior intention. This is almost a good effect, and which is also significant. And then looking here, path coefficients are there. This is a mean and this quantitative interval. These are standards are there. Indirect effect are there, and if there is no indirect effect, though result is there, total effects are there. So total effects you are looking here, total effects, these are standardized total effects are there. So now for everything you are looking here, that results have been grouped into the standardized and unstandardized results. Outloadings are there, and this algorithm is there. Okay, and then settings. So this is a data file, and then execution. Okay, data file, and the basic CB-SEM logic. So these logics have been applied on the data, and then histograms are also available here. So really, it's a wonderful solution, and really now the SmartPLS looks like a Silver Bluet. That means it can solve all your problems. For now, either you have to work on the CB-SEM or the VB-SEM. Now, for the both one, there's only one solution. That is about SmartPLS. So now both you can do in the SmartPLS one. So now at the end, there's one my video which is on the difference between the CB-SEM and the VB-SEM. If you find time, its image you're looking here and its link I have left before below this video. And if you're interested, you can also go through this video. So at the end, thank you very much for watching this video till end. So if you know if there is something you have learned from this video, so you are requested to like and subscribe my channel and share this video with the rest of the other people. Thank you very much.